Hello students, today's agenda is to check homework. We'll be looking at vertical angles and you will be able to do 7.4. Today students will be able to write the proof of vertical angles and use the vertical angle theorem to find angle measurements. And I'm going to show you a list right now of properties that we are going to need, but you don't have to write them because I'm going to give you a copy. So it says addition property, if A equals B, then A plus C equals B plus C. That means that if you add any number to both sides but the same number, then they continue to be equal. The next one is subtraction property. If A equals B, then A minus C equals B minus C. So subtracting to both the same amount, it doesn't affect the quality. It continues to be equal. Both are going to be smaller, but they continue to be equal. Multiplication property, if A equals B, then A times C equals B times C. And division property, if A equals B, but only with the, but C cannot be 0, then A divided by C equals B divided by C. That means that both numbers can be divided by the same number and they continue to be equal, okay? Again, C cannot be 0. Then we learn in algebra distributive property. A times the sum of B and C is equals to A times B. Remember, we multiply times the first one and then the A times the second one. So it's the same as A times B plus A times C, because we're distributing that multiplication of A with each one. Reflexive property says that A is equals A, meaning any line is equals to itself or any number is equals to that same number. Transitive property, which is when we have 3, it says if A equals B and B equals C, then A is equals C. I was showing in class that if a chair looks like a second chair, that second chair looks like a third chair, then just by having that relationship to this middle chair, then the transitive property says that the first one and the last one are also the same. They look the same, okay? But the one in the middle, which in this case is B or B, is the one that relates these two on the sides, okay? So that's the transitive property. Substitution property says that if A equals B, then B can replace A in any expression, okay? And we use that in Math 1 for the substitution method in systems of equations. But yeah, A equals B, then in another equation I can just take out A and replace B in its place, or vice versa, the other way around as well. These are properties of congruency similar to the ones on top, but these are congruent. And reflexive property says that AB, that's a line segment, is congruent to AB, meaning the line is congruent to itself. Angle A is congruent to angle A, again. And sometimes this is because it's used in two different triangles, but it's referring to the same angle, okay? Symmetric property, if AB, line segment AB is congruent to CD, then CD is congruent to AB. All you're doing is switching the order. Same here, if angle A is congruent to angle B, then we can say that angle B is congruent to angle A. That's symmetric. All you're doing is switching the order. And finally, transitive property, if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF, okay? That's the first one and this the third one. And this middle one, both of these relate to the middle line. So that's why we can say, oh, if both are congruent to that CD, then that means that they are congruent to each other. Okay, same with angles. if angle A is congruent to angle B and angle B is congruent to angle C, then we can say that angle A and angle C are congruent to each other. So we're going to use some of these for what we're going to be looking at next. In here, it says, given that TV, line segment TV, and line segment RS intersect at point P, prove that TPS, this angle down here, is congruent to angle RPV, this angle on top, okay? And so the first statement that we're going to say is that angle RPT, angle RPT plus, and I'm going to put the measurement of that angle plus the measurement of angle TPS, so RPT, TPS, meaning these two angles together, plus measurement of angle TPS, are equal to 180. And you can relate it because any two angles that are adjacent to each other over a straight line or a straight angle, it's equals to 180 degrees. But again, you can go to the last lesson to see it. Okay, we also can say that measurement of angle RPT, again RPT, plus measurement of angle RPW, RPV, I'm sorry, okay, meaning RPV and TPV, okay, it's these two angles on top are equal to 180, and again the reason is because there are adjacent angles next to each other over a straight line, and that's 180 degrees. Okay, so those are called adjacent supplementary angles. Adjacent supplementary angles. And this is the same, okay, the same, but is this set right here and then these two right here. Then, because both of these groups are 180 degrees, we can say that measurement of angle RPT plus measurement of angle TPS, is this two, is congruent or equal to measurement. Now I'm going to put these two because this is 180, this is 180. We can say that they're equal to each other. Measurement of angle RPT plus measurement of angle RPV. Sorry, I'm going over the line. Okay, why? Because this is 180 degrees, this is 180 degrees. So they are they're equal to each other. And the reason is the transitive property. Okay, this is equals to this is equals to this, and this 180 is like the intermediate of both, like the middle chair, kind of, okay? Therefore, the chairs on the sides are congruent to each other or the same. Okay, now we subtract one measurement to both that are 180, okay, minus the measurement of RPT, and I subtract it from both sides, RPT. This cancels, and this cancels, and what do I have left? Oh, and that's because of the subtraction property, okay? Subtraction. Meaning that if I subtract equals to equals, then they continue to be equal. And so at the end, I end up with measurement of angle, TPS, and on this side is measurement of angle RPV. Okay, so, and that's what we're supposed to prove. TPS right here is congruent to measurement of angle RPV, okay? By, again, summary. This is 180 degrees together. This is also 180 degrees together. We subtracted from this 180 degrees, we subtracted this piece right here. And from this other 180 degrees, we subtracted the same piece. So if we had 180 minus the similar piece for both, that means that they must be equal to each other. Okay, and that's the proof for vertical angles. Angles that are right in front of each other. Okay. Okay, let me show you how to use or apply the vertical angle theorem. So that was our proof to say that any angle, when we have two intersecting lines that are opposite of each other, even these are another pair of vertical angles, they are equal to each other, they are congruent. Knowing that, we can say that in here, we can find the value of x and then replace that value to find this measurement, okay? So since we know the vertical angles, we just prove it that they're congruent, then we can say that 3x plus 55 is equal to 5x plus 1. So this is congruent to this. They're equal to each other. Why? Because they are vertical angles. And so we start by subtracting. It doesn't matter. I'm just going to subtract even if I have negatives. I'm going to subtract the 5x from both sides. This cancels and I get 3x minus 5x is negative 2x plus 55 equals 1. I subtract 55 from both sides, and so I get negative 2x is equals to negative 54. Why? Because I have a positive 1, negative depth of 55. I subtract and leave the sign of the greater 1. Finally, if I'm multiplying, the opposite is to divide by negative 2. Remember that in division we always carry the same sign. And so this is equals to negative divided by negative is positive, and 54 divided by 2 is 27. So that means that the value of x is 27, but it doesn't mean that the angle is 27. I would have to substitute. So let me do both in here. Let me do 5x plus 1. But now I'm going to substitute 27. So 5 times 27 plus 1. And 5 times 27 is, 5 times 7 is 35, carry 3. 5 times 2 is 10, and 3 is 13, plus 1. And 135 plus 1 is 136. So that's the value of this one right here, 136 degrees. Now let's do the second one, which is 3 times, oops, I didn't put x, but it's okay. 3 times 27 plus 55. And so 3 times 7 is 21, carry 2. 3 times 2 is 6, 8, plus 56. And so this is 6, 13, so it's 136. So as you can see, they have the same measurement, so check. Okay, let's do another example. Okay, this is a little simpler, but at the same time, we're gonna be putting statements and reasoning. So we can say that n is equals to 30, and the reason is because they are vertical angles. And remember that vertical angles are congruent to each other, so we can say that this is 30 degrees. Okay, we can also say that m plus 30 is equals to 180 degrees. And the reason is because they are adjacent. Now I'm concerned whether it's adjacent with E or A at the, it's because in Spanish it's adjacente, adjacent. I think it's adjacent supplementary angles. Okay, and so in here, I'm adding 30, the opposite is to subtract 30 from both sides. So that will be because of the subtraction property. Okay, and we find out that m is equals to 150. Okay, so we can put that in here, 150. And finally, we are going to say that these are congruent to each other. So it's going to be P plus 135 is equal to 150. And the reason is because we already found out that this is 150, this is measurement in expression, so, but they are vertical angles, okay? And so we subtract 135 from both sides. And so P is equals to 15 degrees. Okay, we're doing the subtraction property. And if we replace it, let's replace 15 in P here. So 15 plus 135, 5 and 5 is 10, carry 1, 3, 4 and 1 is 5. And so you can see that it is 150 just like the other, which is M, and so they are vertical to each other, and therefore they are congruent. Okay? We know that these are vertical, they're right in front of each other, so they are equal to each other. So it's 4x minus 4 is equals to 2x plus 10. I don't like to have variables on both sides, so I'm going to subtract the 2x from this side in here. This cancels because 2x minus 2x is 0, and 4x minus 2x is 2x, minus 4 equals 10. If I'm subtracting, the opposite is to add 4. And I'm using all those properties that we were using before. So these are because vertical angles. This is subtraction property. Then we're doing addition property. Okay, those properties that we saw at the beginning. And we get 2x is equals to 14. Finally, we use the division property and we get that x is equals to 7. So this is the division property. Okay, I'm abbreviating those. Finally, what we're gonna do is replace x in one of them so that we can figure out what the measurement of this one is. So let's do this one right here. We can even do it mentally. So 2 times 7, because this is multiplication, 2 times 7 is 14, plus 10 is 24. In here we can also do it right here. 4 times 7 is 28, minus 4 is 24. Okay, and we know that these are either with this one or with the other one, it doesn't matter. I always call it half the orange, right? Because you have the half of the orange right here, the other half is on the other side. But anyways, these are supplementary, they're 180 degrees, so we can say that, and we already know that this is 24, so to find y, we're gonna put 7y plus 20, 7y plus 20 right here, plus the 24 that we found of the other angle is equals to 180 degrees. And that's because they're supplementary angles. They're adjacent to each other. And we combine like terms, and what do we get? 20 plus 24 is 44, and bring down the 7y and equals 180. Next we subtract 44 from both sides, and so 7y is equal to, this is the subtraction property, we get 136. Finally, we're going to divide by 7, and y is equals, how many times does the 7 go into 13? It goes 1 time, and you have 6 left. Then, how many times does the 7 go into 66? It goes 9 times. You can also do the long division in here. And 9 times 7 is 63. So you have 3 left. And you just bring down the denominator. And so that's the value of y. And so this is the division property. Okay, so with that, yes, it is okay to have decimals or fractions, okay, for answers. But with that, you can do now 7.4, which is vertical angles, and have fun.